Hey guys, I hope you're doing well. Here's a quick CPM video to help you get started on some of the problems. As a reminder, you have 8 CPM problems that are assigned on Monday and due on Thursday. I have more details here on Google Classroom. The assignment should pop up on your main stream, and it should also be visible if you go to the classwork tab. Okay, CPM problem set number 2. All right, here we go. I'm not going to give you everything that you need for the problem, but enough to get you started. I already gave you an example actually for how to find the y values. You just plug in x into the original equation. If you plug in 3 for x, you get -8. So I'll help you plug in 0 through 2. Let's get that first half of the table complete. Okay, so again, we're plugging into x squared minus 8x plus 7, our original expression. So let's see, 0 squared minus 8 times 0 plus 7. 0 squared is 0, 8 times 0 is 0, plus 7. 0 minus 0 is 0, and then 0 plus 7 is 7. Okay, so 7 here. And then let's now plug in 1. So 1, 1. 1 squared is 1. 8 times 1 is 8. 1 minus 8 is -7, and -7 plus 7 is 0. Okay, when you're adding and subtracting, you go from left to right. So do 1 minus 8 first, and then add your 7. Okay, 0 here. Let's plug in a 2 now. And then once I have the first half of the table, I'll start plotting some points. Okay, 2, 2. 2 squared is 4. 8 times 2 is 16. 4 minus 16 is -12, and -12 plus 7 is -5. All right, now I can start plotting some points. Let me scale these axes really quickly. I'm just going to scale by ones, but I'm only going to mark them at certain intervals. Okay, so we're plotting 0, 7 as our first point. So that's going to be right here. And then we're going to plot 1, 0, and then 2, -5, and then 3, -8. Okay, and so what you need to do is finish the rest of this table. It's very possible that you might have some points down here. I'm not sure. I can't do this off the top of my head, but once you're done, you should have a parabola. Okay, then you're going to identify the vertex, the x-intercepts, and the y-intercepts. Remember that your x-intercepts are where your graph, your parabola, crosses the x-axis. Your y-intercepts, or y-intercept because you only have one, is where your parabola crosses the y-axis, and the vertex is the tip of the U shape. Okay, so this is not exact. This is just a sketch because I haven't completed the rest of the table, but you go ahead, finish the rest of the table, finish plotting those points, and then label the important parts of the graph. All right, now I'm going to move on to the next question. But first, let's read through some math notes. Zero product property. When the product of 2 or more numbers is 0, one of those numbers must be 0. This is known as a zero product property. If the two numbers are represented by A and B, this property can be written as follows. If A and B are two numbers where A times B equals 0, then A equals 0 or B equals 0. For example, if 2x minus 3 times x plus 5 equals 0, then 2x minus 3 equals 0, or x plus 5 equals 0. Solving for x yields a solution x equals 3/2 or x equals -5. This property helps you solve quadratic equations when the equation can be written as a product of factors. We use the zero product property in Monday's and Tuesday's assignments for Khan Academy. Okay, and here it is showing up in CPM. So just like we did in Khan Academy, we're going to set each factor equal to 0, and then solve for x. Okay, set this factor equal to 0, x minus 2 equals 0, and solve for x. Plus 2 plus 2. I don't have enough room. X equals 2. That's one of my solutions. And then set the other piece equal to 0. Okay, x plus 8 is equal to 0. Solve for x minus 8 minus 8. X is equal to negative 8. That is my second solution. You're just going to do the same for parts B, C, and D. Just solve for x. In D, in the case of part D, you're just going to set x minus 7 equal to 0 one time. The fact that it's x minus 7 squared means it's x minus 7 times x minus 7. You don't have to set x minus 7 equal to 0 twice because you're going to get the same value. You can just do it once. All right. Next problem. The x-intercepts of the graph of y equals 2x squared minus 16x plus 30 are 3, 0 and 5, 0. What is the x-coordinate of the vertex? How do you know? All right. I got ahead of myself there. Let me draw a graph. Let me draw the points, or sketch the points. 3, 0. That would be like here. 3, 0. And then 5, 0 would be like right there. So your parabola is going through those 2 points. I did such a great job of drawing that. This parabola that I just drew isn't exact. I don't have a table of values that I can plot perfectly, but what I can figure out is the x-coordinate of the vertex. If you look back at these parabola notes from very early on, they also showed up in one of the videos for this week. Where is it? Give me a second to find it. Come on. There it is. Okay. Extra note. The x-coordinate for the vertex is halfway between the x-intercepts. Okay, if you look at this specific example, notice that my two x-intercepts are here and here, and the vertex is nice and halfway between those 2 points. So what this means for us is if my two x-intercepts are at 3, 0 and 5, 0, then this vertex, if I write it as a coordinate point, the number that goes in for x, my x-coordinate should be 4, right? Because 4 is halfway in between 3 and 5. Okay, so to repeat that one more time, the x-coordinate for my vertex should be a 4 because 4 is halfway between 3 and 5. Remember, parabolas have symmetry. That means that they can be divided into 2 equal halves. Okay, so make sure to write a reason down here. Okay, it's 4 because, I don't know why my pen is doing that. Okay, because my stylus. All right, you fill out the rest. And then use your answer to parade above to find the y-coordinate of the vertex. And then write the vertex as the point x, y. All right, guys. We, up here, plugged in x-coordinates into the original equation to get y. And that's exactly what we're going to do over here. Okay, if it's asking us to find the y-coordinate of the vertex, we are going to take y equals 2x squared minus 16x plus 30. And we're just going to plug a 4 in for x, and whatever we get out for y is going to be that y-coordinate. Okay, so let's see. Let's use PEMDAS. Don't do 2 times 4 and then square that. Do 4 squared first because e comes before m in PEMDAS. 4 times 2 is 16. 2 times 16 is 32. 16 times 4 is 64. Okay, 32 minus 64 is negative 32, and then negative 32 plus 30 is negative 2. So that number, you guessed it, is the y-coordinate for our vertex. That's my vertex, okay? That's all you've got to do for this problem is, like we did at the beginning, find the x-coordinate by finding the halfway point between those two x-intercepts, and then plug that in to get the y-coordinate of the vertex. Okay. I am going to do one more problem, and then I'm going to stop and create a second part, second video, just because if I make a video that's too long, YouTube won't let me publish it for some reason. That happened recently with a different video that I had to redo. Okay. 8-83. Oh, never mind. 8-74. Factor each quadratic below completely. That's just what we've been doing. But first, I'm noticing that there's a 2 that can be factored out first. It might make our lives a little bit easier. If I factor out a 2 from 2x squared, I'm left with x squared. If I factor out a 2 from 2x, I'm left with x. And I'm left with a 2 here. Okay. Make your diamond and your generic rectangle. X squared down here, negative 2 up here. X squared times negative 2 is negative 2x squared. Take the negative x, put it down here. Negative 2x plus x is negative x, and negative 2x times x is negative 2x squared. Let's put those back into our generic rectangle. X, 1, and negative 2. Okay. Length times width. Again, I don't know where my stylus is doing that. Okay, I've factored completely. Factoring completely means factoring out a common factor first, if there is one, and then factoring to get length times width. I'll give you a hint for part B. You are going to factor out a 4 before you do the rest. Okay. So again, like I said, I'm going to stop here. I'll pick back up in part 2. Stay tuned.